expecting you put it where the sun is it, would unwind to the circle of Jupiter A, monster totally shaky and going to explode. They are among the most observable impacts of radio energy in the entire universe, conveying more energy than a billion suns. Betelgeuse is a red Goliath star, assuming you put it where the sun is it would connect with the circle of Jupiter. Monstrous, absolutely inconsistent, and moreover, going to explode. When we think about stars, we no doubt imagine irrelevant, glimpsing things in the night sky. Basically, this is how we see them from down here on Earth, yet stars are something completely different. As a matter of fact, maybe quite possibly one of the most prominent stars, Betelgeuse is fundamentally more critical than our sun. For quite a while, this star has perplexed ages anyway. Truth be told, something additional upsetting has been happening with Betelgeuse, making inspectors and other very achieved individuals extraordinarily concerned. Go along with us in this video as we investigate the grand new data about Betelgeuse, its coming obliteration, exactly as expected by the James Webb Space Telescope, and how this new advancement will impact our universe and our lives here on Earth, as made sense of by physicist Michio Kaku. Betelgeuse is a gigantic marvel, a giant star that has fascinated cosmologists for so long. A Greek space expert named Antonius was the first to find that this star is so immense that it tends to be viewed in the night sky from Earth, particularly during winter. In the event that you're into cosmology, you've without a doubt seen or caught wind of the star. The becoming flushed orange star means the upper left shoulder of the Orion heavenly body. So you see, the star is obsolete and thus far may be one of the most glorious stars in the evening sky. Yet one thing about frightening little creature Juice's brightness is that it doesn't stay dependable, rather it differs. This change is one of the great properties of the star, but it isn't the only one. We ought to explore some of Betelgeuse specific properties. The greater part of the stars you find in the night sky are a long way from Earth. The nearest star is 4.2 light years from Earth. In case you dismiss how the term light years gives a sense of distance, picture it this way: consider moving at the speed of light for a whole year. It's been shown how light can cover a distance of 186,000 miles. Thus, the distance light can cover in a year is essentially comparable to 1 light year. Predicting you crunch the numbers, you'll have billions of miles. So when we say the closest star is 4.2 light years away, it means it is regardless billions of miles from Earth. Look at this: some stars are farther, and Betelgeuse is one of them. Betelgeuse is tracked down around 600 light years from Earth. So assuming that you somehow wind up going to it at the speed of light, it would in any case require 600 years. We can't move that quick, not even our speediest space rockets can. However, the star can in any case sparkle so brilliantly in our sky. If you're considering how Betelgeuse can be so great regardless of its distance, that is a result of its unique attributes like size and quality. Betelgeuse is on numerous occasions more enormous than our sun. Its range is recognized to be commonly that of the sun. Tragically, it shows up as a disk in space while utilizing current telescopes, while various stars show up as nearly nothing places of light. This is accepted to be an impact of the reactions at the external layers of its air. In regards to mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass utilized by space researchers. 1 solar mass is like 2x10 to the power of 30 kilograms. Specialists can't pick the specific mass of Betelgeuse since there are no other planetary bodies circling around it to look at it with, and obviously we can't gauge it straightforwardly from here on Earth. At any rate, this makes Betelgeuse on numerous occasions heavier than our Sun, the brightness of Betelgeuse goes from size +0 to +1.6 in more undeniable. Terms Betelgeuse is ordinarily more amazing than our sun, no great treat it. Was nicknamed a red giant at any rate. The quality of Betelgeuse doesn't stay solid. It differs as change is due to its pulsates, or in other words, Betelgeuse expands and contracts. When it extends, it gets more brilliant. At the point when it contracts, it reduces. This cycle can endure for 10 to 100 days, or indeed even significantly longer. A clever property of Betelgeuse is that its surface is canvassed in dull, attractive spots. The attractive field here is far more grounded than at the normal surface. Anyway, the drawback is that these strong attractive spots slow down the progression of hot gas to the star's outer surface, making the star cooler in these areas. The reality that Betelgeuse has so many of these spots contrasted with our sun makes sense of why it is cooler than our sun. Notwithstanding its size and splendor, the sun likewise has its own dim attractive spots, but those on Betelgeuse are a lot larger and altogether more numerous. To give you an idea, the spots on Betelgeuse can be 2 times as broad as Earth. Betelgeuse flaunts an attractive field that is a large number of times more ground than that of the sun. This field is the explanation that when seen through a telescope, the gases on the external layer of bug appear to be whirling around or twisting. Betelgeuse has a surface temperature of around 3,500 K. This low temperature adds to the low energy discharged by the star and its feeble red variety. Frightening. Betelgeuse is a red star, but it wasn't always red. It was yellowish, something like a long time ago, like our sun. Over the long run, the variant started changing to orange-red, and then about 1,000 years ago, it slowly began changing into the red star we know today. This reality has led scientists to believe that the star is developing. Betelgeuse produces as much as several times more energy than the sun. It would have been a man contender to Earth's sun if it weren't so far away. The way that Betelgeuse, which is 600 light years away, can still be seen and related with the naked eye around evening time is incredibly striking. Our sun is simply 8.3 light minutes from Earth. That's why it's so strong. If Betelgeuse were just a little closer, we would also be able to see it during the daytime, but if it somehow managed to replace the sun, it would consume or displace the Earth and the other 4 planets close to it because of its enormous size. Other than whether it were to match the sun in size, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is an extremely giant star located in the star group Orion, about 600 light years from Earth. Its immense size is potentially one of its most striking parts. It is ordinarily more significant than our sun with respect to its size and could easily include the circle of Jupiter if placed at the center of our solar system. This unbelievable size permits Betelgeuse to show up as a disk instead of a point of light when seen through strong telescopes. Not at all like most different stars. Despite its huge size, Betelgeuse isn't the most giant star. Its mass goes from around 12 to 19 times that of the sun. This variety in mass estimates is due to the difficulties in precisely estimating the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a giant heavenly body. The brightness of Betelgeuse is another key characteristic. It varies reliably over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.55 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be several times more brilliant than our sun. This change is ascribed to its pulsates, intermittent extensions and contractions, brought about by inside cycles within. The star, when Betelgeuse expands it, becomes brighter when it contracts it, darkens. These pulsates can last for a long time, adding to its dynamic appearance in the night sky. Betelgeuse surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red hue typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, showing dark magnetic spots on its surface where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a colossal brilliant star, but it will ultimately meet its end in a glorious cataclysmic explosion. Betelgeuse is a massive star advancing toward the end of its life, and its potential fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand rapidly and potentially lead to its collapse, eventually becoming a supernova. In the process, the immense energy released by Betelgeuse explosion will send shock waves throughout space, triggering the formation of new stars and potentially influencing the surrounding planets and their systems. The death of Betelgeuse will change the cosmic landscape and will mark the end of its existence. As Betelgeuse nears the end of its life, it will begin shedding its outer layers in a dramatic display. These expelled materials will be blown into space at high speeds, creating a nebula, a colorful cloud of gas and dust. This process is known as a stellar wind, and it's a characteristic event for dying stars. The material ejected from Betelgeuse will enrich the surrounding interstellar medium, providing the raw material for future generations of stars, planets, and potentially even life. The ultimate fate of Betelgeuse is to become a supernova. A supernova is an explosive event that occurs when a star has exhausted its nuclear fuel and can no longer support its own gravity. The core of the star collapses, causing a violent explosion that releases an enormous amount of energy, outshining an entire galaxy for a brief period. The shock wave from the explosion can trigger the formation of new stars by compressing nearby gas clouds. This cycle of creation and destruction is one of the key drivers of the evolution of the universe. However, Betelgeuse's explosion, while dramatic, will not have a direct impact on Earth due to its distance at 600 light years away. The explosion will likely be visible as a bright new star in the night sky, but it won't be close enough to affect our planet significantly. The effects of such an event could, however, reach across vast distances, influencing nearby star systems and their evolution. Once the star has exploded, the remnants of its core will either collapse into a neutron star or, depending on the mass, into a black hole. Neutron stars are incredibly dense, with a mass several times that of the Sun, packed into a sphere only about 10 to 20 km across. Black holes, on the other hand, have gravitational fields so strong that nothing, not even light, can escape from them. In either case, Betelgeuse's death will mark the end of its existence as we know it, but it will also pave the way for new cosmic phenomena. The material it ejects into space will eventually condense to form new stars and planets, continuing the cycle of creation and destruction that characterizes the life of the universe. While Betelgeuse may no longer shine as brightly in the sky, its legacy will live on in the cosmic dust that it leaves behind mind for now, though we can continue to marvel at the brilliance of Betelgeuse, one of the most fascinating and massive stars in the night sky. Its continued pulsations and fluctuations remind us of the dynamic and unpredictable nature of the universe, where stars are born live out there, cycles, and eventually die, creating new possibilities in their wake as scientists continue to study Betelgeuse and other stars like it. They gather valuable insights into the life cycle of stars and the evolution of galaxies. The data from instruments like the James Webb Space Telescope and other observatories help to deepen our understanding of these celestial objects and the forces that govern them. With every discovery, we get closer to unraveling the mysteries of the universe, from the smallest particles to the largest galaxies and everything in between. In the future, beige death and the resulting cosmic events could offer further opportunities for learning and exploration, sparking new questions about the nature of life, death, and rebirth in the universe. As we watch the stars, we are reminded that we are all part of this ever-evolving cosmos, and the story of Betelgeuse is just one chapter in the grand narrative of the universe's ongoing transformation